Hello and welcome to Saras's classes. Today we are going to solve one problem from Test of Mathematics at 10 plus 2 level, which is very well known by Tomato. This book is published by Indian Statistical Institution to help the students in their preparation for ISI entrances. Okay, so let's see what is in this question. Let box of x denote the largest integer, positive, negative or 0, less than or equal to small x. Now define a function y is equals to fx, which is box of x plus root over x minus box of x, be defined for all real number small x. Okay, now we have to sketch on a plain paper the graph of the function fx in the range -5 to 5. This is the first portion, and the second portion says that we have to show that given any real number y naught, there is a real number x naught such that y naught is equals to f of x naught. Okay, before before we start the solution, we need to know one concept. Suppose we have y is equals to f of x. Okay, and the value of fx is suppose the given function, that is box of x plus root over x minus box of x. Now let that x is equals to a particular case, which is suppose 2.4. Now the value of box of x is 2, as this is the integer this is the greatest integer which is less than or equal to small x. Now define small x in curly braces, which is nothing but the integer portion, sorry, the fractional portion. Therefore this is equals to 0.4. So we can say that if we subtract the fractional portion from x, we get box of x. So we need this equality. Okay, now let's again back to the solution. Therefore from this we get box of x plus root over x in curly braces. Now we know that this will be always a fraction, therefore 0 to 1, always a fraction or 0 or 1. Okay, not always fraction, there is equality at 0 and 1 also. So this implies that root over x in curly braces is greater than equals to the value itself. Therefore we can write that if we add box of x at both sides of this inequality, we get box of x plus the fractional portion. Okay, therefore we can say that f of x is greater than equals to small x, and the equality holds in this portion when x takes integral values. Okay, now we have to draw the given function in the range from -5 to 5. Okay, this is the given graph. Okay, so we have solved the first portion of this problem. Now we have to solve the next portion, so let's get into it. in this next portion we have to show that given in real number y naught, there exists a real number x naught such that y naught is equals to f of x naught. Okay, again y is equals to fx is equals to given by box of x plus root over the fractional portion of x, as it is in between 0 to 1, hence we can say that root over the fractional portion is always real. That's always true. Okay, so this implies that f of x is always real, and this implies there is a x naught for all y naught belongs to R and x naught belongs to R such that y naught is equals to f of x naught. So that's the proof. Okay, so that's all for today. And we Stardust's classes provide different study materials and mock test papers for ISI entrances, so you can join us. And for further details, you can check our website also, which is www.stardustclasses.com. And please subscribe our YouTube channel to get the notification first. Thank you very much.